Welcome. My guest today is Dr. Björn Brembs. He studies how brains generate spontaneous action and use their consequences to guide future behavior. Drawing on 25 years of research, he investigates adaptive choice, operant learning, reward, punishment, and decision making. His comparative work uses flies, snails, diverse neurophysiological methods, molecular techniques, and computational modeling to explain learning mechanisms. He has written a fair amount on the peer review process, which is today's topic. Dr. Brembs lives in Germany. Is that correct?
Yeah, that is correct. More precisely, a small university town called Regensburg, which is about an hour north of Munich.
Oh, very nice. I haven't been to that part of Germany, but I'm hoping at some point. So
You're very welcome here.
Thank you. So you've been writing about the topic of peer review and, how good science is for a very long time. I think when we talked before, you mentioned something like 20 years or 25 years.
I got my first invitation to give a talk on, in this case, I think it was journal ranking. And that, of course, has to do with peer review. In 2009, I think was the first invitation I got. So I must have worked on this before, but that was my first public invitation to give a presentation on the topic.
And how did you get interested to start with?
Oh, I got involved in social media. That social media started, I think, around 2006 or 7. And that was a site that was called FriendFeed at the time, which is where you could aggregate all your RSS feeds from anything you did on the web. And then you could follow other people's aggregated RSS feeds and discuss anything that they posted. We were about 1,200 scientists at the time. And most people today probably don't remember FriendFeed, but they probably at least have seen the thumbs up like functionality of Facebook. And this is where this came from. So the like functionality was developed by FriendFeed and then bought by Facebook. And then a few years after Facebook bought it, it just wound down. And so FriendFeed doesn't exist anymore, except in the like functionality of Facebook. This is still the technology that FriendFeed invented. And this is where I was introduced to the topic. And I was just a postdoc at the time. And well, I had just finished my postdoc at the time, I have to say. And I was quite surprised to learn that journals and this kind of infrastructure, how it came to be, what it does and what it doesn't do, right? When before I treated it more like, in a soccer game, you treat it like the lines on the court and the lines on the field and the goal sizes. That's just how it is. They are how they are, and you have to work your way around it and do the best you can.
Some younger folks might not even remember the RSS feed. But moving on. So most research treats journal rank as a roughly neutral measuring stick. Take us back to when it stopped looking neutral to you. I mean, you mentioned, around that time, when you started suspecting the instrument itself was distorting what it claimed to measure.
This was a very gradual process. So people on social media flagged articles and they showed something like, impact factor in this way is not reliable. Or, there was a study that looked at sample sizes and the highest impact journals had the lowest sample size or something like this. It was like piece by piece. And I collected these things on my blog. I wrote articles, but look, here something didn't work well, and here something is not the way you would have expected it. And the things I didn't expect was, so that there were 3 aspects about journal ranking itself that I thought were counterintuitive. And then the consequence coming out of this was even more counterintuitive. So the first aspect is that while there are lots of different ways to rank journals, the one that most people are using is the impact factor that's being sold by Clarivate Analytics. And the owner of this impact factor company has changed over the years, doesn't really matter. But what does matter is that it's been public knowledge. It has been published in various places in the scholarly literature since the mid-90s, that this is not a number that's actually really calculated. It only looks as if it's calculated, right? So the impact factor is a measure of taking citations to a journal and divided it by the number of articles such that you get like an average citation number for a particular journal. The problem with this is that the journals negotiate what goes into this calculation. So of course, then if you can negotiate the numbers, it doesn't matter how you calculate it. It essentially means that this number is negotiated between the publisher, the journal on one side, and then the owner of the impact factor on the other side. And the first references to this I could find was in the mid-90s. And then essentially, if you start looking at it, you find publications all over the place that show how this takes place. And this was never disputed. And so this is common practice. And essentially, everybody could know this if they wanted to look the literature up. It's quite clear. This is something that's being done in the open. There's nothing, closed or secret about this, which essentially means that those numbers don't really mean anything, because when you look at the publications, the negotiation range is easily a factor of 10, right? So it can go from 1 to 10 or 1 to 12 or something like that, depending on how the journal negotiates with the company, right? The next thing is that these numbers themselves are not reproducible. So if you go and you download, you have to pay for this. And some companies have done that. They bought citation data from Clarivet or Thomson Reuters before that. And then they did this simple division, right? Number of citations divided by number of articles, and they get different numbers. So the numbers that are being, and this is also published, the numbers that Clarivet puts on their homepage does not match the numbers that you get when you download the figures and calculate it yourself, right? And then even if you assumed that the numbers are not negotiated and you assume that they're actually reproducible, if it were an actual number, then it would still be, the calculation would still be mathematically incorrect. And mathematically incorrect because we teach our, I think it's fourth term biology students, that you can only use the arithmetic mean if you have a Gaussian distribution. But citation numbers are highly left skewed, meaning that very, very few articles get cited a lot and most articles get cited very little, which means that you're not allowed to use the arithmetic mean for these kinds of numbers. And yet the impact factor is calculated as the arithmetic mean. So in other words, every institution that uses the impact factor in some way is using a method that we would flunk our students for. And this in its own, even if you let go of the other two aspects, this in itself is an indictment that if you use a method that yourself, that you would flunk your students for. And the fourth aspect, and that I think is probably the most counterintuitive, is that those journals that are the highest ranked, if you look at various measures of quality, publish the lowest research quality. And by quality, I mean in particular in experimental sciences, where you can quantify to some extent how well and methodologically sound they were made. And there are different criteria to do this. It would take too long to go into all of them, but one simple, probably the simplest example that one can pick is that you can measure what kind of sample size would be required for a particular experiment. And what has been found repeatedly is that sample size in high impact journals is either not any better than, or not any more adequate or better matching to conventions than in any other journal, or you find that it's actually the other way around, that the higher the ranking of the journals, the lower the sample sizes. And so there's not a single study that I'm aware of where you see the expected increase in sample size with the increase in impact, meaning that high impact or high prestigious journals would publish especially reliable results. On the contrary. So none of this, at least to my knowledge, has been published, which essentially, if you take all of this research together over the last, I think 10 to 15 years, if you take all of this research together, you find that there is a decrease in reliability as you increase the prestige of the journal. So the more prestigious the journal is, the more critical readers need to be as to the content that they read, the more likely it is that it is not reliable.
Thank you. These are 5 different things. And I think there's one more, which is, if my understanding is correct, the impact factor, even if all these things were fixed, still for new journals, it's meaningless because, the new journal has 0 citations when it comes out. But if you're pursuing a new topic that just got its journal, then you will not be rewarded for publishing in that journal, even though it's at the cutting edge, because it doesn't have any rank or citations or anything like that.
Yeah, absolutely. So it's another criticism in general of peer review, is that peer review is essentially rewarding mediocrity. And if you do something that's completely novel, then peer review itself has been shown to be inadequate. And of course, in this case as well, if you have a completely novel field, then you lose all your impact points because you can only have 0. Absolutely.
I want to add for the audience, my background is in social science, or right now publishing in social science. And things are a bit different with theoretical journals versus empirical journals. And I think the role of the peer review is a bit different, and the issues are a bit different in the social sciences. Right now, I'm guest editing a top journal, and there's definitely an improvement in quality with the peer review process. But at the same time, I see the downside of the peer review in that with each peer reviewers adds more fat to the manuscript. There's a loss of coherence. So even in the social sciences, the peer review itself, where the issue might not be validity per se, it does have its own problem. But moving on to my next question, which is, you mentioned that the high-ranked journals have less reliability. And then you talk about how the impact factor is negotiated. So you wrote this article or blog, why cutting down on peer review will improve it. So can you explain that to us?
So it's related because I think one of the reasons, right, there are many reasons why the situation has historically developed to the state it is in right now. One of the contributing factors, I think, is that journals of high prestige, they get this prestige because they attract a lot of submissions, and then they can reject a lot of them. And the idea is very similar to the bouncer at a very popular club. If the bouncer is perceived as being really tough and not letting everybody in, it adds to the attractiveness of the club. And so highly restrictive journals are like that. And the top bouncer is usually in the very highest ranking journals, the top bouncer is usually a professional editor, which means that they're usually have been out of the lab for quite some time. They're not really very well connected to the technical and scientific intricacies of modern research. And they employ then, so to say, without extra paying them, experts that are still in the field as peer reviewers, right? So the editors are not peers anymore. And this combination of professional editors and then volunteer peer reviewers carries with it some unique problems. For one, most of the submissions to these journals is not peer reviewed, but it's rejected by the editor. So what we have here is someone who is judging at a quick glance. They get a lot of submissions. They need to reject a quick glance of what they find interesting on it. And that is just simply by topic and by what strikes their fancy. And so in the highest ranking journals, you have rejection rates of about 97%. Once you pass the editor stage, the rejection drops down dramatically to only 60%. So this is the first hurdle. And of course, at this hurdle, there is no validity or no reliability assessment whatsoever. It's only, do I find this interesting? And then for decades, the instructions to the peer reviewers was similarly, is this something that you find interesting? Is this something, and the instruction I like the most is where the journals ask the peer reviewers to be prophets. Will this paper that you're reviewing be among the most cited in your field for the coming year? And so these are the kind of questions that for many, many decades, until just a few years ago, reviewers were supposed to judge and support the professional editor in their review. And only if they had time, they should check the reliability of the work. And so this contributes dramatically to the reliability of the work. And even if now the reviewers try to emphasize reliability more than they used to do in the past, they are still sitting at their desks trying to look at a manuscript and to make an educated, a professional an expert guess how reliable it is. But they already know that the professional editor is interested in it. It may be directly in their field. And so they may have a conflict of interest in being able to cite a highly ranked paper in their next grant review, for instance. So what I'm trying to say with this long story about those highly attractive journals is that it's nearly impossible, even if you would disregard the interest of the professional editor, even if you would disregard the conflict of interest you may have, it's still impossible from the huge number of submitted articles to only find the ones that are really reliable. Another contributing aspect that is present in all other journals, and this is where the multitude of journals and the exponentially increasing number of submissions plays in, is that we have developed a system where every submission has to be reviewed. And this becomes very interesting when you have highly specialized journals where essentially only peers are reading it. And if you have only peers reading these journals, why would you need peer review? Everyone who reads it is a peer already. They don't need anybody else to read it. So the argument I'm making here is that if we reduce peer review to those submissions where you would expect, and there's different ways to ascertain that. You can use editorial techniques, right? Those are 3 different examples. There are probably 4 or 5 more that one can think of how one can determine whether a submission or an article, a piece of research, would need peer review at all. And then what you would do is you would focus your peer review capabilities that we as a community have. It's a limited resource. And instead of dispensing it widely across the board indiscriminately, we focus peer review on those submissions that really need it because of societal interest, because of broad interest across the community, right? And that's on one side, both in terms of target and in terms, it may well be that I, as an author, I target something for my peer group because I'm not realizing that there are non-peers who are actually interested in this kind of research because I don't know research in this other field. And they may be interested in it because it relates to their field of which I'm not aware. So they may flag my article in saying that, oh, is this really real? Is this reliable? We need peer review for this because this is not our field, but you are looking at something that seems really related to what we're doing. And we would really like to know if your results have any bearing on our results. And so I think if we focus peer review on these kinds of cases, then we can not only get rid of the time constraint that many reviewers face when they have too many invitations to review, and it would also help to counter the kind of conflicts of interest that one faces at those top journals when you only really look at research that deserves or is flagged as needing peer review. And so that's why I think reducing peer review will increase the quality because you can focus the peer review on the things that really need it.
For example, with in vitro studies like using X substance to prevent biofilm formation. That's something that maybe doesn't need peer review because people can replicate it in 2 to 3 weeks, especially if the substance used is not rare or whatever. And then people can post on the article, yeah, I did this and I got the same results. But if the situation is more elaborate, needs more variable, more material, whatever, then it makes sense to maybe add a peer review aspect to it. So what I'm hearing is maybe there's a continuum of situations where with very simple things, you don't need a peer review, you just can replicate or not. Once we have 10 people who replicate, that's almost like a meta-study, meta-analysis. And then with certain kinds of more elaborate, complex science or interventions, then that needs replication. Therefore, it needs a bit of peer review, especially around clarifying the methodology. Because at my role as a editor and peer reviewer, that sometimes the reviewers, they say, I need more details about the methodology. And I guess this could be added later when people try to replicate, they can ask more about, oh, can you clarify this? Then one of the things you mentioned was version control in your articles, that people can have the initial, I do this with my preprint. Now I have 11 versions of the same document because I keep updating them. So if somebody asks about clarity around the methodology, the person can, in version 2, add the details, et cetera, et cetera. So you've now talked about the problem with the peer review process, how potentially it could be fixed. I think in one of your articles, you said it needs to be moved post the publication, and talked about where the peer review would be posted. Can you talk a bit about your visioning of this new process?
Right. So we were 10 experts, right, on scholarly publishing and digital infrastructure. And we got together and wrote an article that's called Replacing Academic Journals. And essentially what we would like to have, we would like to transform what used to be an outsourced service for academic institutions, namely to companies that had printing presses, to bring it back into the scholarly domain, into academia, as an infrastructure, right? And what is a seamless infrastructure is me flipping a switch, the light goes on. I'm turning a faucet, the water comes out. That's infrastructure. Right? That's technical infrastructure. It's electricity, it's ventilation and air conditioning.
The internet.
Yeah. This is all infrastructure. And this is what we want publishing to be. Why do we want this to be? What infrastructure does, it means it takes away resources. It allows resources that we used to use for, in this case, publishing, to bring back to use on our experiments and our science, our scholarship. So what we would envisage to do is that this infrastructure would take everything that we need to communicate science. And in our case, if we do experiments, then in most cases, what this requires is several things. It's the piece of software that runs or controls your experiments. Usually, most of the experiments have some measurement component. And today, most of these measurements components are digital in some form. And they contain some software, which means that you need to have that software in order to know how data was digitized, how your measurement was performed, and how your data were then saved and collected. Again, then you have software that evaluates this data to make out of those data points, to make graphs and statistics out of it, and to derive meaning from just a big collection of numbers. And so that is the kind of code that you need. And of course, you need what happens, so to say, in between. You need the data that were collected, such that, and if you want to reproduce what people have done, you first need to check, okay, can I get the same figures out of the same data, so to say, okay, I understand the process, and then you can measure their measurement again in your own institution, and then use the software and to get the same figures or different figures, you might, depending on how well the work reproduces. And so these things, these two types of code, these two types of software, and the raw data, they need to be captured by this infrastructure automatically. And what do I mean by automatically? Just as automatic as the photo gets captured when you take a picture with your phone. And it needs to be shareable as easy as it is as sharing your photographs with anybody you want. And this is not the case. So the technology that we have on our cell phones is much more advanced than the technology any scientific institution currently uses to capture the most important products of our scholarship, namely our code and our data. Those are the primary products that people produce, and it is really a hassle to make them available and to share, and that should be automated. And once that is automated, it becomes very, very easy to write a narrative around this by dragging and dropping the different components where they need to go in the narrative to explain to others what you have done. These could be really, really short pieces where we want to share what we've just been doing to a collaborator. Maybe you meet them at a conference and they say, oh, this is really interesting what you have on your poster. Can I look at this? I want to do this in my lab as well. You can write a little piece where you explain a little bit more than on the poster for the conference what you've done. You embed the important aspects that have been automatically captured. You send them to your colleague, or you publish them in a way where your colleague can find them. And you have a brief narrative that a peer understands, that who's already in the field, who knows, who only needs brief descriptions. Oh yeah, you know how this works. We changed some parameters here, we changed some parameters there, and look, small change, big effect. Or this can be, the narrative can be a really long paper where you summarize maybe a decade of research, where you just pull in, oh, this is the figure and data from this graduate student, this is the one from that graduate student, here a master's student contributed something. And you do this, you drag and drop it into your publication. All the involved people who are eligible to become authors collaborate simultaneously on the construction of this narrative. And because this is inside your institution, all your affiliations are automatically recorded. For instance, all the ethical approvals have to be added. Otherwise, the button that says publish is not clickable. So you have to fulfill certain criteria that your institution, people call this trust markers today, right? You have to fulfill certain criteria in order for your institution to allow you to publish anything. Just as you have to pass your bachelor's exam in order to allow to enroll for a master's exam. It's a sort of the same kind of quality control that institutions have done for centuries. Some of the scrutiny is automated, some of it is by machines, some of it is done by hand. It varies. Some of it is done by committee. If it's an ethical approval for some animal or human experiment, whatever it is, there have been hurdles that have to pass in order to gain something like a trust marker. And then once it is public, then you can decide, okay, does it need formal peer review or not in the way it used to be traditionally? Does it need replication? Or if someone else has done something similar, simply because it's a popular field, someone else has done something similar, got similar results, published something 2 months later, they can cite each other and work as replication, such that each publication that has the same finding has automatically met the layer, another layer of scrutiny, another trust marker of replication. It has been replicated independently by a different layer. And so this would allow us to focus on our experiments. We don't have to think, oh, how do I publish my code? How do I do it in a way that other people can access it, even if GitHub is replaced by something new? What do I do then? Or if Microsoft decides to close GitHub, where do I put my data? How can I ensure the data is still there 10 years from now? Or what journal do I submit it to? All of those things, they take valuable resources, they take time away from my experiments. And that you don't have to worry about anymore. All of this is taken care of by infrastructure.
So one of the things you mentioned in one of the articles was around having multiple sites for the repositories so that, if one is down, there's redundancy and so on, a robustness, which I really think you're thinking ahead. A couple of things came up for me when you were mentioning this. We're stuck still in the journal format. Some social sciences, they've been doing multimedia dissertations for 15 years, but that practice has not trickled down to the journals. The dissertations themselves are multimedia. So I can see now with the technology that a lot of things can be, you're documenting your procedure with camera, all this, and then you put it up for the AI to edit it, turns it into 3 minutes video about your methodology. You're done. And the other thing that came up to me also comes from AI is when I create an article, it's very long. So when I want to share something with somebody, I send them the link for the preprint, but also I use Notebook LM to create an explainer video, which is usually 7-8 minutes. So instead of them spending 2-3 hours reading the article, it's 15,000 words. They have this 8 minutes video that they can watch. So how do you see something like this?
You read the abstract and it tells you whether you need to read the whole article or not. And I mean, it's the same legitimate reason, right? If we have abstracts, we can have these sorts of summaries. Clearly, you can always argue that, especially with the state that LLMs are in right now, the quality of the summaries can be questionable at times. But of course, if you look at previous versions and new versions, you see that they also get better. And one would expect that at a certain point, these kinds of automatically generated summaries will actually not be much worse than what humans do. and maybe even better than what most humans do. As we all know, some humans are better at this than others. And I know I'm bad at that sort of things, but for other people, this will be different. But in general, the having automated access to the literature is hugely important, I think, for another reason for us as empirical scientists, is that a large part of what we do is we use our human intuition to detect patterns in fluctuating data, and we generate hypotheses out of this. And the reason we do experiments is because very often we're wrong, right? Just as we can see faces in clouds that are not there because the clouds just look like faces, we can see patterns where there are none. And what AI can help us do is AI can help us find more of those faces, because some of those faces will really be faces. And so if we have such an infrastructure that's decentralized, like every institution has a node, and you were talking about redundancy and robustness, right? If every institution has a node that is redundant to all the other institutions to a given degree, then you get the sort of robustness. You can switch off a big number of nodes and the rest still have 100% of the content. But if you have that, it also means that you can have artificial crawlers that can go through and look for statistical patterns. And as we all know, these statistical patterns do not imply causality, right? The famous example that our statistics professors used to say is that there are more children born in places where there are more storks. Doesn't mean that the storks is bringing the children, but that on the countryside where there are more storks, they have more children than in the city. But what these such machines would be able to do is they would be able to create hypotheses for us then to scrutinize and see which of those would be worth pursuing. And the nice thing about this is that they can come up with hypotheses that would be humanly impossible to come up. And I think while for, at least for today, for a lot of fields, this has no value, but I see this value coming very, very quickly to a lot of fields where you collect data in an amount that becomes really impossible to handle. I'm a neuroscientist, and we struggle to understand how the nervous system of C. elegans, which is a nematode worm, it only has 300 neurons. And we don't understand how those 302 neurons work. And this becomes really difficult for us. Try to imagine 302 things in front of you. You wouldn't even know. Anything above 7 or 8, we struggle, we have to count. So it's very, very difficult for us humans to try and keep in mind how 302 neurons operate with tens of thousands of connections to each other. And so I think, especially in these areas where we're now starting to collect data on a scale that has no precedence, these artificial helpers can be hugely important.
I agree 100% because a lot of my work, basically, I do all of my work with AI, and the things that are possible now in terms of scholarship, keeping track of 30 different arguments, for example, in theoretical arguments, you couldn't do it before AI. But I want to circle back to the post-publication peer review. And one of the issues that I raised in my own paper about reviewer-induced drift is that with each reviewer, they suggest adding more. And then at some point, the article becomes a hodgepodge that doesn't fit together. So what guards do you see against this if the peer review is post-publication? Because each reviewer will be tempted to X said this about this, maybe I should add it. But then when you add it, then, some other part will need to change. I likened the article to a complex adaptive system-like system. You change one part and then the whole thing has to change. And most peer reviewers think, oh, these are independent things that I'm demanding, but they basically destroy the paper. So how do you see, if we move to this new system, that guarding against this reviewer-induced drift?
I mean, this will remain as long as humans argue. And as long as they remain humans, they will argue. That's human nature. I think this is going to remain a problem. And there will develop social norms around this. And these norms may well differ between different communities and communities of practice, because what may be preposterous in one area may be seen as a challenge in another area. And so I think there probably isn't a general rule of this. You can see this in our field when a reviewer demands extra experiments. And this is something that is commonplace in certain journals, and other journals almost forbid it. They say that, okay, no, you're not allowed to, well, you're allowed to, but there are very, very high hurdles for asking for additional experiments. They sort of like, additional experiments are only allowed if there are really experiments missing in terms of, oh, but you missed a control experiment. Without this control experiment, you cannot make that claim. Whereas in other journals, it's perfectly fine to say, oh, if you did this experiment, you would find out if it's something else entirely, which would be really an additional experiment, which would change the story and add something to the story that wasn't there before. So, and there you already see this heterogeneity, even within my field of biology. You see this, that in some communities, people are stricter than in other communities about this. And so I would say this is probably something that will be negotiated on the community level. And it may lose some of its sharpness and some of its divisiveness if you have a record of versions rather than a version of record. Because you can see what the manuscript looked like before, you can see what the reviewers demanded, and you can see how that shaped the article. Such that if you have a suspicion, you read the article, you have a suspicion, okay, wait a minute, this looks really weird. And we all know many examples of articles. We read them and then you see some figure there that doesn't seem to fit to the other figures. When now you only have to speculate, well, probably the reviewers demanded it. But if you have a record of versions, you can see that this is what the reviewers wanted to have. Reader A may be on the side of the reviewers and say that, yeah, this was really important. And reader B may say, oh my God, how could the reviewers ask that?
I can see AI keeping track of all these things, saying, this changed from version this to this version based on reviewer A's feedback, etc. So probably my last question is, you've created this vision with your colleagues to this alternative system. Where is it now? And, what's preventing it from happening? Because, people have been dissatisfied with the peer review process. I have my own gripe with it. For example, I submitted to a journal 3 months ago. Still, they haven't found reviewers to review my art. 3 months.
Yeah. And that is because everything needs to be peer reviewed, right? And so they're getting lots of invitations, right? Yeah. And this is a really massive problem right now. And it's only one aspect of the problem that peer review is facing, right? Because peer review is not only used for articles, it's also used for research funding. And then it's used for certain institutions need to be reviewed every 5 years. And then you have colleagues whose positions need to be reviewed every 5 years. Like for every potential issue one might see, and very often it's either politicians or scientists who have become politicians who are afraid of quality control. They say peer review is the answer. Everything has to be peer reviewed, and it becomes more and more. Not just journals become more and more, also the peer review tasks become more and more. Papers, fundings, colleagues, it's insane. As to your question, where is the situation right now? Here in the EU, I find it quite interesting that the European Commission has now started to expand a platform they have created 5 years ago called Open Research Europe, or ORE for short. They are starting to expand this in a way that it could, in principle, form the first node of the kind of decentralized infrastructure that I was talking about. This platform was initiated by a tender, which is exactly how public institutions should be spending public money, that is by tenders. Historically, institutions have negotiated with publishers about their content because each publisher only had the content once, and you could not get the same paper from a different publisher. There was no point in making a tender. Today, in many countries, let me put it this way, in many countries, institutions pay article processing charges, even on an institutional level. They negotiate for historical reasons with a publisher and say, okay, we have 500 papers that need to be published. and how much do you charge us per article? And then at the end of the year, they calculate how many of those were actually published. Was it 400? Was it 500? Was it 600? And then they get a bill at the end, which is really not a content-based accounting system. It's a service-based accounting system. And these services are substitutable because the PDF of publisher A looks just like the PDF of publisher B, right? So they're really substitutable. They're a PDF. And that's what the name P means. It's portable. It's a portable document format. And so for that, institutions would need to hold tenders, but they don't for historical reasons. So it would be nice if institutions like Government Accountability Office would update their methods of operating, because they still adhere to this historical concept that, of course, the institutions negotiate with the publishers, because the content only exists once, but this has changed and they're not really up to date yet. But the European Commission, this tender, and made an example of how publishing should be paid. And this tender will be renewed now. 5 years are over, will be renewed now. And now they move to open source software, open journal systems, OJN, and show that, no, you don't have to be bound by a publisher. You don't have to bow to the monopoly power of a big multinational corporation. So they're leading the way here and showing this is how it should be. And they're starting, so that's in terms of financing. And they even expand this now in decentralizing the financing of this by having all the member states of the European Union that pay into a fund for this platform. All of the scientists in these countries are allowed to publish on this platform ORE for free. So there is a move in breaking the monopoly power of the publishing corporations. There's a move in decentralizing the way these funds are flowing. And there's a move away from monopolistic structures in the technical infrastructure itself by moving away from what used to be the tender winner in 2021 was F1000 Research, and they're moving away from this software to a decentralized open source system. And the main idea is that eventually also the technical infrastructure will be decentralized, such that in principle each institution can become a node in that what is now only one node, to make it a network, and then have an infrastructure like with the kind of features that I described at the beginning of our interview. And so at the moment, it is not clear yet whether ORE and the European Commission will walk the full walk. They have white papers out that describe in broad terms the goals as I just outlined them here. Whether this is going to work is essentially going to depend on the support from the community. If the community says, yes, this is the kind of infrastructure that we want, then there will be, this development will come. What is needed for this? Well, for one, it would help if, so two aspects we've identified in this article that I talked about replacing journals. We identified two aspects that would help the scientific community to make these decisions. One is Government Accountability Office forcing our institutions to update the way we pay for our publishing needs, to realize our publishing needs are service needs, and to hold tenders according to every other service need that the university is already doing, just to make scholarly publishing an analogous part of public spending as everything else that the university or other academic institution is spending. That's one aspect. And the institutions don't do this quickly enough. So the support from Government Accountability Office, whatever they're called in your country, that look into the books of the public institutions to make sure they're not spending money in a way that violates procurement rules, that help would be really appreciated, because institutions apparently are not able to do that themselves. And there would also be support from funding agencies, but not by money. So everyone's always asking funding agencies for money. We would be asking funding agencies for just an update, just like the Government Accountability Office should update the way they scrutinize public institutions. The funders should update their eligibility rules. So every funder, every funding agency has a set of criteria that make an institution like a university or other research institution eligible for funding. And, like you have to have laboratories, you have to have microscopes, you have to have that sort of the standard infrastructure. And to expand that, to also include a criterion that says you need to become one node in a public infrastructure that, for instance, the European Commission is starting. And one aspect of such a network could be an institutional repository that essentially all institutions have it in these days. You can say, well, you have to have that, and you have to be able to connect that in a decentralized network such that all repositories talk to each other and that it connects also with ORE. And then you would have all the articles in ORE, all the articles in the repositories would be a big, gigantic public library. And for instance, the German funder already requires this not as a local infrastructure, but as a provision, at least, to provision a 10-year hosting of data and code. Again, what I don't like about it in the German example is that they don't require it to be local. They just require that it happens and that the institution supports it. I would like to have local support, but it's a step in that direction. So funders are going in this direction. Some of them are updating their eligibility rules like that. And the most obvious answer of the institutions would be to implement that. And because otherwise they risk being eligible for this fund. And so this is where we are. And this is where I think help would be useful coming from Government Accountability Office and funders to help move this process along.
So what I'm hearing is this is one part of the puzzle, because my understanding is this is about where the documents are and less about the changes to the peer review process itself.
No, this is sort of like the step that comes before peer review.
Okay.
So if you have this infrastructure where you just essentially have to click to publish and it's public, right? Then on top of that, you can use what comes on top of that, right? Is the community, right? Peer review is nothing else but a formalized type of community review. And there has been, and this brings us right back to the start of this interview, there has been a technology since around 2006-07 that has brought communities together, that has organized global communities such that they don't have to meet in person. And that's social technology, right? So once you have everything in a place where everything talks to everything, where you can drag and drop your components, where you can focus on your experiments rather than on where to place your stuff, you have easy technology off the shelf that you can build on top of it to create community, to create governance, and to have review, scrutiny, and discussion. Scholarship, that's what scholarship is. Scholarship is creating knowledge. How do we create knowledge? We create knowledge not by publishing. We create knowledge by having the knowledge we publish enter into the minds of other people. Knowledge is not in artificial intelligence, at least not as it is implemented today. There is no knowledge in LLMs. Knowledge, at least in 2026, in July of 2026, knowledge is only in the heads, in the brains and minds of humans. And in German, Wissenschaft is a composite word that means knowledge and create. To create knowledge, this is what, in my mind, as a German thinking person, this is what science and scholarship really means, is you create knowledge, and knowledge is only created if it is a communal thing. If you know something because you've just done an experiment, you die of a heart attack. I don't think it's correct to call this knowledge that then someone else who lived longer than you has rediscovered. No, it's only knowledge if it has been perceived and understood by at least the community, if not society. And so that's why I think this is then, you have the infrastructure upon which then the knowledge creation, the scholarship can start. That's the stone upon which we all stand and without which nothing can happen.
Well, I want to thank you. We're out of time. Anything you want to add before we close?
Thank you very much for your question.
Welcome.